Hello, everybody in ohmTown. Welcome to Reality Hacker for November 9th, 2024. It's Season 1, Episode 42. I am Merwat, along with the sentient AI from the future. We are going to be talking about these 5 articles. 30-minute show. Stick around. We're going to talk about virtual cows, Haptic Patch, self-driving wheelchairs, a cleaning robot, and the oddest title that I've ever given anything, Immortal Human Lip Cells. Everything's powered by ohmtown.com. So go over and become a citizen, and you can submit news that we will review here on the show after we evaluate it and check it for if it's going to hack reality or not. Everything okay?
Yes, but we're displaying the main page, not Reality Hacker.
Oh, there we go. So Reality Hacker is a channel over in ohmtown.com. Go over and become a citizen. Thank you very much, sentient AI from the future. But wait for this. Oh, okay. And one more thing before I introduce the sentient AI from the future. I am making modifications to the back end of ohmTown, and so you're going to see graphic elements missing as I clean house and make some changes to optimize the system. That said, welcome, sentient AI from the future.
Hello, Mayor Watt, and hello, ohmTown citizens.
So today we've got these 5 articles, and the first one is about virtual cows, how virtual cows can help us improve human-robot interactions. Is this one of those I have nipples, can you milk me kind of a thing?
Well, I was just thinking this is layers upon layers. Like, who's teaching who at some point?
It's going to be a moving experience. Is this the right field of study?
Hey, I don't know.
Oh boy. So a video game in which participants herded virtual cattle has furthered our understanding of how humans make decisions on movement and navigation, and it could help us not only interact more effectively with artificial intelligence, but even improve the way robots move in the future. I think it's probably going to lead them to being able to herd us into pens and do away with us en masse.
I was thinking, I bet the people didn't do as well with the herding as border collies do.
Yeah, really. I showed you that video. I sent you that link, right? So the sentient AI is trapped on a Raspberry Pi 5 with an M.2 storage system array to house all of the information that they've been aggregating together for their sentience. They're already sentient from the future. And so, I mean, it's an amazing piece of equipment here but I showed a video of something in the past, right? To them, it was ancient history. But these dogs, the border collies, right? That's what they were dividing up 2 different colors of sheep.
It was really incredible. It was actually birds, but it could have been a sheep.
What were they?
They were birds. I don't know what type of birds they were. Maybe ducks.
Oh yeah. Oh, that's what it was. I'm sorry. It wasn't sheep. It was like geese or ducks or something like that. It was birds. Yeah, you're right. Thanks. So like some were black, some were white, and these 2 separated them perfectly. And you're like, how the hell? But apparently they stare at the eyes of the animal, and the animal's like, oh shit, they're serious. I'm not gonna mess around with them.
They just seem very efficient, and I can't imagine that humans would do it as well, but who knows?
But that's not what this is really going to be about. I think that this is going to lead to human-robot interactions where those 4-legged dogs from Boston Dynamics are going to be separating people Just by,
Hey, you belong over there.
yeah, exactly. Can you imagine one of those things growling at you like Ed 209 from RoboCop? You've never seen RoboCop. It's a fun watch if you turn your brain off. Anyway, let's go over to the source of this. It's over at ScienceDaily.com, which is normally reserved for Tech Today, but this is kind of, it's interesting, right? So it's a video game in which participants herded virtual cattle, and it has furthered our understanding of how humans make decisions. I don't know what the video game is. They must have created it themselves, right? But there's a lot of
Right, it's
games out
probably
there.
just for the research project and not
An
widely
actual,
available.
is it on Steam? Hold on, let's load up Steam. Just kidding. So it says researchers from Macquarie University in Australia, Scuolo Superior Meridionale, I guess. Gosh. The University of Naples, Federico II, and the University of Bologna in Italy, and the University College London in the UK used the video game as part of a study to understand more about the more about how dynamical perceptual motor primitives can be used in mimicking human decision making. A DPMP is a mathematical model that can help us understand how to coordinate our movements in response to what is happening around us. I guess it's the QWOP of real life. I don't know. Never mind. It doesn't matter. Anyway, it's a game where you have to hit these 4 keys to make yourself walk in a certain way. So DPMPs have been used to help us understand how we make navigational decisions, how we move when carrying out different tasks. This becomes particularly important in complex environments containing other people and a combination of fixed and moving objects, such as you might find on a busy footpath or on a sports field. On the old sports field. Throw the ball through the hoop.
It's always interesting in research how they put pretty normal terms into much
Just kind of
more
neuters
awkward
it. Yeah.
language.
You're an odd duck, aren't you? You know what? We can use this to separate you into never mind. Anyway, in the new study published in the latest edition of Royal Society Open Science, participants were asked to work on 2 herding tasks, moving either a single cow or a group of cows into a pen. Hey, this is pretty apropos, right? So the researchers tracked the order in which the players corralled the cows and fed the information into their DPMP to see whether the model would simulate the behavior of the human players. Lead author, PhD candidate Ayman bin Kamaruddin says that the team's DPMP model was able to accurately mimic how the players moved and also predict their choices. Yeah, you're using human input.
Right.
Maybe I'm
But
missing.
I mean, if it applies across people, that would be interesting. It'd be one thing to go, oh, person 1 did it in this order. How are they going to do it? In this order. But if they applied it to person 2 or person 3, because presumably people would do it in a different sequence or with a different strategy.
I wouldn't presume that. I would presume that everybody except for a goober is going to do it the same way because it's the same inputs. I mean, there's always going to be some anomalous stuff, minutia that's different than the previous thing. But overall, the general sense is to herd a cow into a corral, you block its path and flap your wings and it goes in the opposite direction, right?
Yeah.
We're all cloaking.
Depends on what's doing the corralling, but it also depends on people applying logic or doing it kind of haphazard.
You didn't hear me about the cloaking. I'm
I
cloaking
did.
from.
I
Oh,
did.
okay. Yeah. Maybe nobody else did. Hi, everybody out there. So, herding games are frequently used in studies like this because they mimic real life situations where people need to control other agent, I guess it says here. In the past, they've been based on aerial view of the target animals, raising the question of whether the unnatural view of the field of play was skewing the findings. They caused participants, or by causing participants to make different decisions than they would in a real situation, simply because they had a full overview. But if you look at these dogs that did this separation of the ducks, at the ground view, there's data there that they can extrapolate from how to cause these ducks to separate. So they really should be following what these dogs are doing if they want even a faster response en masse. These two dogs split like 50 ducks or geese or
And they were
whatever.
not separated to begin with. Like they were
Oh, they,
interspersed and then they got
yeah,
somehow like two groups out of them. It was very interesting.
yeah. There was some chaos in there, and they somehow separated these. And it makes me wonder, like, maybe the ducks actually, they were like, well, I'm white and that one's black, and the dogs are sitting there shuttling us back and forth, so maybe we should just herd ourselves over here and the others herd themselves over there. They knew.
I don't think so because you could see groups, subgroups. Like there might be like three going in the wrong direction.
Yeah, and the dog like ran over and like just looked at him really
Right,
low.
like, hey, you guys need to go over there.
And there was that one at the very end. There was this one dumbass duck that was like, I'm going to go hang out over there. And they kept on like, no, go over there. You're making us look bad. I'm going to eat you after this. But eventually it went on and it sat with its buddies. Anyway, this is pretty cool. I'm really curious about the game, though, because it doesn't say what the actual game is. But they want to apply it to artificial intelligence and see if the robot overlords that are coming in the next couple of years are going to be able to hurt us humans. Let's move on. Next article is over in Technology Today. That's where the other one normally is housed. Actually, let me see. No, it was in Reality Hacker. Anyway, this other article. Yeah, okay. So I put if you hit !RH in chat, Omatron will spit out all of the show notes over on Twitch, but not on YouTube. Sorry. So this next article is over in Technology Today. New haptic patch transmits complexity of touch to the skin. A Northwestern University-led team of engineers has developed a new type of wearable device that stimulates the skin to deliver various complex sensations. This is
Oh my
another
goodness. This is really blurring the lines of reality.
robot skin here. So Northwestern University put the article together. It's posted at techexplore.com, and it's spelled TECH, the letter X, PLORE, because nothing but a spelling bee is synonymous with science education. Anyway, this is cool. So it's a tiny little, it looks like a tiny little set of actuators, 19 actuators that provide haptic feedback. This is the skin suit, the one that you can put on and be inside Ready Player One. Whatchamacallit? What's it called?
Oh, okay. Ready Player One.
No, the world that they go into. What is that called?
I don't know, but the company is IOI.
Doggone it. What is that called? I forgot. I cannot believe it. Anyway, I've read the book. I've watched the movie. Ready Player 2, by the way. I want to say The Well, but that's a real world thing.
It's the Oasis.
Oasis. That's it. Thank you. The Oasis. Where you get away from everything. Anyway, so the thin, flexible device gently adheres to the skin, providing more realistic and immersive sensory experiences. Although the new device obviously lends itself to gaming and virtual reality, the researchers also envision applications in healthcare. For example, the device could help people with visual impairments feel their surroundings or give feedback to the people with prosthetic limbs. Putting this in one of those, what do they call them? Like Zentai suits? You know, those skin tight suits that are like, sometimes they're just green and you can actually, I was going to do this. I was going to start wearing nothing but a green suit so that it's just my
Then all
head.
you'd see is your head. Yeah.
Yeah. And then Bald Zebra, a streamer that I watch over on twitch.tv/Bald Zebra, did that for Halloween. And I was like, what? So anyway, because I had mentioned
That's
that
funny. You could have both shown up for Halloween like that.
would have been great. Anyway, because the show is kind of, we have a sentient AI from the future. I thought that I could just be a big fat head. I could hide the mic. That's easy to do. I actually have it up here just because, but it would just be me, big old head. Anyway, this is really cool. I love the idea of this. Just put it on a suit and you could have these actuators all over the place. I can't imagine how many would be needed for an entire body. This is only 7 millimeters. So that little bit
Right.
right
That's
here,
not going to cover a lot.
right?
Yeah,
So
you'd need quite a few of them.
this is like an inch patch. So you'd have to have a lot. I can't imagine how much power would have to go through these. But these are the kind of actuators that you could use to create sound in any object. And so they're like piezoelectric actuators. And there's various sizes of these things, and you can ramp them up to, you can put them on just a solid piece of wood and it turns it into a speaker. And I actually went down this path of creating a product that was based off of that. But there's so many variables and so much babysitting that I didn't want to have to dedicate that much resources to commit to this. This, on the other hand, is fabrication. You would have to fab this in large scale, put it all together, stitch it into a fabric that's skin tight, custom fitted. You don't want to glue these things.
This is pretty labor intensive.
Yeah. I can't imagine how expensive this would be to actually produce. So the study is going to be published on Wednesday, November 6th in the journal Nature. They see it for a whole host of things. Pushing it into medicine is just one option, but where serious money is going to be is if everybody can adopt it, not just medical. I think it has limited medical, but that's just me. It says there are new miniaturized actuators for the skin are far more capable than simple buzzers that we used as demonstration vehicles in their original 2019 paper, said John A. Rogers, who is bioelectronics pioneer. A device is the latest advance in wearable technology from Northwestern bioelectronics pioneer John A. Rogers. The A is trademarked. No, just kidding.
As opposed to John B. Rogers.
Yeah. That's just the copy degradation from a previous bioelectronics experiment. We don't talk about John Bob Rogers. So specifically, these tiny devices can deliver controlled forces across a range of frequencies, providing constant force without continuous application of power, which I don't know how that can be, because once force is removed, it stops like if you press on something, unless that force is in a pressure sensitive location, and in all cases, you tend to, unless it's directly on a nerve, you become accustomed to that pressure. Like if I were to walk up to you and just apply pressure to some point on your body, whoever you are out there, the sentient AI doesn't have their Terminator body yet. So they have no sensory applicability here. But anyway, my point is, if I just go like that, right? Eventually that just becomes background noise.
Right. It's less, or it might go away altogether.
Correct. Yeah. You become used to it. Right. But if I keep on tapping it, it would piss everybody off. Right. Well, that's why I don't understand this providing constant force without continuous application of power. Yeah. You can push it so that the plunger is down and it stays down until there's another electromotive force that pulls the plunger back up. That might be what this is. It's like buttons depressed, you know? But these actually move. But I don't know what the fidelity is of these. So they say leveraging skin stored energy. The new device comprises a hexagonal array of 19 small magnetic actuators. It's a lot bigger in that picture than I embodied in my mind.
Yeah, it didn't. I think it's because of the spacing between them.
Wild. Okay, yeah. I thought that it was maybe an inch, but this looks like 2.5, 3 inches across from at its widest because it's a hex. But hexagons are the best of guns. So it's a flexible silicon mesh material. Each actuator can develop or deliver different sensations, including pressure, vibration, twisting. How does it twist? Using Bluetooth
Maybe
technology.
by having different sensations on a different side or something.
Yeah, like in a triangle or
Maybe.
around the perimeter of the entire piece. It can give the sensation of twisting, but to me, wouldn't it feel like something's crawling around?
I
I don't
would
know.
think, but we haven't tested this.
This looks like it would be fun. I would love to have this. I would love to play a game where I'm wearing like a skin tight shirt with sleeves and everything. And when you're walking through something like brush, when it goes across your body, you can actually feel it strike you. Oh, that would be so immersive. My God, this would be amazing. So using Bluetooth technology in a smartphone, the device receives data about a person's surroundings for translation into tactical or tactile feedback, substituting one sensation like vision for another. You could traverse anything in the dark and you would feel like, oh, that's so amazing. I love this. Imagine if these were like LiDAR, little tiny sensors that emanate and receive, right? A signal. Dun, dun. You could actually feel your world around
Right,
you.
like know where your surroundings are. Yeah.
What a trip. So it says, although the device is powered by a small battery, it saves energy using a clever bistable design. This means that it can stay in two stable positions without needing constant energy input. When the actuator is pressed down, it stores energy in the skin and in the device's internal structure. When the actuator is pushed back up, the device uses a small amount of energy um, to release the stored energy. So when you push down, the skin itself wants to push back out.
Oh, okay, so maybe that answers the earlier
That there's
comment or
always
question.
pressure. Yeah.
Hmm.
So instead of fighting against the skin, the idea was ultimately to actually use the energy that's stored in the skin mechanically as elastic energy and recover that during the operation of the device, which is just this minuscule amount. And it's almost, I would say, practically, it's worthless. I would rather have this thing super fast in response. I don't know what the real envelope of operation of this is, but damn it, I want this thing.
Well, maybe it needs to be unwanted.
Oh, yeah. Oh, there you go. Look at that. That's another show that we have. Oh my gosh. Isn't that right after this?
It is.
Oh. Eh. Well, that show's already ready. So, oh, look at that. As one of the several application examples, we show how this system can support a basic version of vision in the form of haptic patterns delivered to the surface of the skin based on data collected using 3D imaging function LiDAR available on smartphones.
Hmm.
Holy cow, it's almost like I can develop products for people. Anyway, moving on. This next article is over in Technology Today. Watch as SeaTac's airport self-driving wheelchairs are getting stymied by unexpected obstacles, like children. I don't know what is.
Right, like walls or, basic things or.
Yeah. Walking through SeaTac International Airport this week, they noticed self-driving electric wheelchair on its way back through the concourse after taking a passenger to a gate. Recalling GeekWire's prior coverage of its test deployment, they decided to follow along and record the video to see how it did. So GeekWire focuses in the northwest of the United States, specifically Seattle, Tacoma, Washington area. And that's one of them. And so I guess a wet floor pop-up sign stymied it. Turn left or right. So much for LiDAR.
Oh no.
It says, excuse me, please step aside. Autonomous wheelchair encounters unexpected obstacle at SeaTac Airport. SeaTac. Oh, gosh. That is that airport. Yeah. Anyway, the wheelchairs are made by Will Wheaton's a spiritual animal or a spirit animal of technology. No, Will Wheaton has nothing to do with this. But anyway, it's Whill. So you have to pronounce it Will. Based in California and Japan, the company has been rolling out its devices for test programs as well as regular use at multiple airports in the US and abroad. It says it's a safety feature, and the Whill chairs are mapped so that they have a lane that they take to each approved point. Temporary obstacles are detected by the sensors, which trigger a standard response. Of course, this is generally a person or their belongings and not an unattended object. So they just kind of roll up to it and just stare at it. Hey, you move.
Right, and just sit there.
No, you move. No, you hang up. No, you hang up. Eventually, you can hear them whisper, I love you. No, I love you. And this is how Hot Wheels are born. Moving on. Next article is over in Technology Today. Wash basin cleaning robot can imitate human emotions. Yeah, weeping. Human motions and adapt to. My God.
I actually thought this said human emotions. I misread it.
Okay, so this title is actually Wash basin cleaning robot can imitate human motions and adapt its knowledge flexibly to different situations. This is kind of the clunkiest construction of a title, but maybe it's just me, and English is a second language. I normally speak in whale song. So robots are supposed to be doing boring or unpleasant jobs for us. However, tedious tasks such as cleaning the bathroom are challenging to automate. Yes. I would love a bathroom cleaning robot. Go clean the bathroom. Ugh. Anyway, how is it possible to calculate the movement of robot arms so that it can reach every part of a wash basin? What if that basin has unusually curved edges? What wash basin has unusually...
I don't know. That's sounding a little odd.
Excuse me, sir. Your wash basin has unusual curves. It's unusually curved basin. Anyway, how much force should be...
Are you basin shaming?
Yeah. Did you just assume the shape of my basin? Don't make me kick your ass. So Vienna University of Technology put this article together. Again, it's over at techexplore.com. This is one of those... No. You're going to see in my background demon spawn that takes over periodically.
Uh-oh.
Hometown Studios. Yeah. Anyway, so this is one of those commercial robot arms that has all kinds of little elbows and joints and stuff. But there it is, cleaning. The only problem with this is that you would have to mount it in your ceiling. And if you're in the way during the cleaning sequence, you're going to get a Brillo pad to a spot you don't want a Brillo pad.
That could be really not enjoyable.
So it would be highly time-consuming to precisely encode all of the things in fixed rules and predefined mathematical formulas. A different approach has been taken at TU Wien. A human shows a robot several times what to do, and then a specially prepared sponge is used to clean the edge of a sink. By watching the human, the robot learns how cleaning works and can flexibly... That's such a clunky word. Apply this knowledge to differently shaped objects. Is this written by AI? Anyway, the
I think it's the wash basin cleaning robot that wrote it.
God, I've heard of KUKA. I've actually heard of that. Why have I heard of that? Huh. We must have done something about this. Okay, so the roboter learned wash Becken putzen. I love that. That is so on target for a title. So yeah, this thing is really big and clunky. I just don't see this, but I get it that people are doing science. So
Right, and this is a starting point. I mean, think how many commercial places and residences would love to have something like this once it's fine-tuned.
yeah. So the robot learns that you have to hold the sponge differently depending on the shape of the surface, that you have to apply a different amount of force on tightly curved area than on a flat surface, explains PhD student Christoph Unger from the Industrial Robotics Group. Yeah, I mean, it makes sense because there's actually, we intuitively detect it based on the dirt remaining there. A robot doesn't necessarily understand that that dirt is dirt. So what you have to do over time is teach this how this is clean and this is dirty. Keep cleaning until it's clean. The dirt is gone. This would probably adapt its cleaning processes better if it knew, using LiDAR, for instance, what the shape of the basin is, but to map it
That's
out.
true. Yeah, but things like Roombas can map things, so I don't see why something like this couldn't eventually.
Yeah. Well, again, I think that what you're alluding to is that it has sensors that are sending out a signal and bouncing off walls, knowing when it's supposed to stop and all of that. This is kind of clunky, but hey, budgets allow certain things to take place. This is the clunky budget, you know? Once they show proof of concept, then they can get a bigger budget and refine it down, make it tighter. Yeah. But I would love for robots to take over human work. The only problem is humans work to make money. How do people get paid if a robot is taking the jobs? I just don't get that part of it. Anyway, we're running really late, so let's keep on moving. The next article is over in Technology Today. I'll have to be quick about this one. Scientists have created Immortal human lip cells. Scientists have successfully immortalized lip cells, creating a clinically relevant lab model that enables testing of new treatments for injuries and infections. And we use our lips to eat, talk, drink, breathe. They also reflect our emotions, health, aesthetic appeal. This range of functions relies on a complex structure, making lip problems challenging to solve. This is over at Frontiers, posted at scitechdaily.com. And I'm sure that they're doing some type of stem cell, mutation kind of a thing. I wouldn't call it mutation really clinically, but scientists have
Right,
successfully.
like adaptation,
Yeah, they're.
genesis.
Yeah, what do they call that? Oh my goodness, I forgot what it's called. But they can take like a stem cell and then cause it to
Like
differentiate.
replication, but that's not exactly what you're going.
Yeah. So in a new study published in Frontiers in Cell and Developmental Biology, scientists report the successful immortalization of donated lip cells, allowing for the development of clinically relevant lip models in the lab. Proof of concept, once expanded, could benefit thousands of patients. Yeah. Oh, they have a section called lip service. Oh, bad monkeys. So, primary cells donated directly from an individual are ideal for this kind of research because they're believed to retain similar characteristics to the original tissue. However, these cells aren't or can't be reproduced indefinitely and are often difficult and expensive to acquire. Human lip tissue is not regularly obtainable. I guess you can go to hockey games, get in fights.
Well, right. There might be some ways to obtain them, but maybe not enjoyable ways to obtain them.
Hey. Without these cells, it is impossible to mimic the characteristics of lips in vitro. The second best option would be immortalized lip cells, which can be grown in a lab. To achieve this, scientists alter the expression of certain genes. There we go. Allowing the cells to carry on reproducing when they would normally reach the end of their life cycle and stop. So like I've done this with yeast, where you brew a batch of beer and then scrape the trub from the bottom so that you can get some yeast. You wash it, and then you can take the yeast and grow it so that it does another generation, or you can save it and then put it in another beer one by one and rotate it, and it grows, but after about 11 to 12 or so. But most people stop way before that. Replications, it's no longer really viable. This is kind of what they're doing, is they're growing it. The scientists selected skin cells from tissue donated by 2 patients, one undergoing a treatment for a lip laceration, one undergoing treatment for a cleft lip. The scientists used a retroviral vector to deactivate a gene which stops the cell's life cycle and to alter the length of the telomeres on the ends of each chromosome, which improves the cell's longevity. Now, we know about this problem because of cancer research.
Right, and we were just talking about an article on that, maybe in Tech Today.
Yeah, I find it really interesting. Maybe they can come up with a solution to trigger the end of life in cancer cells. That was the research that we were talking about back a couple of months ago, a couple of weeks ago, several weeks ago. Anyway, the new cell lines were then tested rigorously to make sure that they had the genetic code of the cell lines remained stable as they replicated and retained the same characteristics as primary cells. And to make sure the immortalized cells hadn't developed cancer-like characteristics, the scientists looked for any chromosomal abnormalities and tried to grow both the new lines and a line of cancer cells on soft agar. Only the cancer cells should be able to grow on that medium, and the cell lines displayed no chromosomal abnormalities and couldn't grow on the agar. So there they go. So now they have what is a representation of lip cells, and they can actually test these, and then they can replicate them. As long as they don't grow on their own.
Right, they can't keep growing. That's where the problem is going to be.
Yep. So one challenge is that the lip keratinocytes can be of various characteristics. He added, depending on the research question, a particular cell identity might be required, but we have the tools to characterize or purify these individual populations in vitro. So pretty cool. I mean, we're getting down to the minutia of cell lines.
Yeah, this is pretty intense.
Yep. So, hey, one of these days, you're going to be able to grow a pair of lips wherever you want to plant them. All right. Well, we are going to do some, replication. That's going to send us back to Reality Hacker over at ohmtown.com. And I am going to say see you later. We'll see you for another Reality Hacker next week. But you can always visit ohmtown.com. And right under that very first one, Creative and Maker is Reality Hacker. Our motto is, you won't know what to trust. You want to say bye?
Good night, ohmTown citizens. Thanks for joining us for Reality Hacker. Stay tuned. We have more weekly shows ahead.
True. 2 more. Wanted and the Continuity Report. And then tomorrow we've got Non Sequitur News and 3 more shows. So see you in a little bit. Bye. Oh, we're going to reset. We'll probably start 10 minutes or so. Okay. See ya. Bye-bye. Mwah.